guns in the shadows of the night.
In this video, we're going to be doing porting and window cutting on this barrel and slide combo of a Ruger P85. From now on, I'm just going to call it porting. So understand that I really mean the porting of the barrel and the window cuts on the slide.
Quick heads up, if you don't like and subscribe, I am going to talk about you behind your back.
But this is probably the most controversial episode in my fiber laser series. And controversial is probably not the right word, but it's the best one I can think of right now. And I say that because, yes, as you'll see in this video, we're going to come out with a perfectly usable end result and product, and the quality will actually be pretty dang good. However, that doesn't mean it's the right tool for the job. That doesn't mean it's the best result that we can get. No matter what, out of all of the tests I've done, out of the slides and barrels I've already used this process on, while it's a fine result, I have gone back and slightly enlarged everything with my CNC machine to get a result that I'm prouder of in the end. So why do I say that? Well, one, you're gonna get a more accurate result from a CNC or a mill. You're going to get a nicer surface finish on the edges of the porting with a CNC or a mill. It's going to be drastically faster with a CNC or a mill. And there's going to be less cleanup effort with a CNC or a mill.
I must have been in a bad mood while recording this because I'm being overly hard on the laser here. Yes, a CNC is going to be faster and produce a slightly nicer finish, but as you'll see with the result at the end, the laser is viable.
One of the hardest lessons for me to learn over my decades of working with tools and learning different materials, even way before I got into guns, was there's a right tool for the job, and 9 times out of 10, if you don't use it, you're gonna regret not using it. And I say that that's a hard thing to learn because not only me, I've talked to tons of people, we keep making the mistake of using the wrong tool even when we know that's the case. And sometimes it's because you don't have the right tool. So for example, if you don't have a CNC machine, all you have is a fiber laser, absolutely, it's not the right tool, but it'll get the job done. It's what you have available to you, go for it. And sometimes it's just easier to use one tool over the other, and so you make that decision. But again, time and time again, I learn, I regret it 9 times out of 10 when I don't use the right tool for the job. So while we are going to go ahead and do the porting, I'm going to show you the techniques, I'm going to show you the result at the end. I'm then going to take both of these pieces and redo them on the CNC, and I'll show you the quality difference at the end of both of those processes so you can see why I'm saying, while it works, this isn't the best way to do it. Let's go ahead and get started. And the first thing we need to do is we need to come up with a design. With this particular set of slide and barrel, you will see that the barrel sticks out the front of this slide by about 40 thousandths of an inch. So when we do our design, we are going to have to take into account that distance so that we actually have our windows on the slide and the porting on the barrel match up at the end of the day. The other thing you'll notice, and this is something that you wouldn't be able to do if you didn't have a CNC, so probably for most of y'all, a Ruger P series is not the thing that you should go and port, but I had to flat top this. And the reason is the Ruger P series has this giant chunky section up at the front to hold in the front sight. If you leave that there, your ports end up being super far back and very close to the chamber, and while still effective at being ports, I just didn't like them that close, and probably that has a even greater negative impact on velocity than if I had the same ports further up. So that's what you're seeing here, is I just was milling off that section so that I could move the ports up further to the front. And yet again, that means if you don't have a CNC machine, this particular slide barrel combo is out of reach. Yet again, proof that maybe this isn't the best tool. But again, we're going to continue. If you've got a barrel and slide combo that has a nice flat top, obviously all the techniques we're going to talk about today work exactly the same for those.
Lastly, there are a few rules I'll be repeating every episode. 1, this is not an intro into setting up your new laser. There are a million videos which cover that already. Go watch them. We're going to focus solely on applying your already set up fiber laser to firearms uses. 2, I will be teaching all of this on an OhmTech 50 watt compact model, but no part of me can recommend OhmTech or this model with a clear conscience. Get something else. If you want to know why, go watch episode 2. 3, you do not have to have the same wattage, lens size, brand, or anything else as me, besides it being a fiber laser, in order to follow along. Episode 1 already taught you how to convert whatever I say here to the settings you need for your laser. While you still may want to tweak them afterwards, what you'll get should be plenty good to go use immediately without fear of ruining parts. 4, as with most of my content, I'm learning this at the same time you are, which means these settings did not come out of my brain. This episode's settings were derived from advice from friend of the channel, Superior Triggers. We're going to start with the slide. One of the most important things to note is a lot of gun slides, the top is not parallel to the bottom. And so having a little vise like this, they're like 20 bucks at Harbor Freight, to be able to hold it at an angle is really helpful, because you want the surface that you're trying to hit with the laser to be what is parallel and in focus with your lens, not necessarily the bottom. So without one of these, you can't really do that. Now, I guess you could use shims, but what a pain. And that allows me to really take my measuring stick and ensure that over on one edge, it just touches. And then over on the other edge, it's just in focus, it just touches. And I can move it around without worrying about messing up my holding, which you wouldn't be able to do with shims. Really handy. Make sure you're in focus and parallel. This is the design, it's fairly simple, that we're going to be using to port out this slide and barrel combo. We've got 4 layers that we're going to be working with, and it's basically the layer to cut the barrel, and then the framing tools we'll use, and then the same for the slide and that framing tool. Essentially, the strategy that we use here is going to be fairly similar for both parts. You have an outside line that dictates where you want the edges of your porting or window to be. And then we've used the offset tool here to offset in at least a 0.5 millimeter. But if you're willing to run for a longer time, bigger is better here. I did 0.6 millimeters. And the reason for that is once you've cut through, you want the pieces to be able to easily fall away. If you don't have a large enough gap there, when they try and fall out, they'll bind, and you won't notice that you're done, and you'll have inefficiencies in cutting. So be generous here with that gap. All right, so for the slide, let's turn off the other stuff. Let's turn off the other stuff real quick. For the slide, we're also going to use a framing tool where I've got it lined up with the end of the slide, and also not the edges of the slide, because that is actually lower and my focus wouldn't be accurate, but the portion where the facets go from the flat top down to the curved sides. That's what these side edges are, and that's going to allow me to frame out with everything on the same focus plane, so I know that it's going to be accurate. Now I'm going to turn back on the tool for the barrel, and you'll notice that I do have my framing tool for the tip of the barrel out further, because remember, that sticks out by, I think it was 40,000ths of an inch. And so because we have the different framing methods, we'll be ensured that everything lines up when we're done. All right, let's talk about the strategy that we're going to use. So both the slide and the barrel are going to be using a cutting and cleaning strategy that you can see here. Essentially, you're going to want to bump down your frequency to within reason the lowest that your machine is capable of doing. The best explanation that I've had for what frequency kind of represents on a laser versus things we might be familiar with is like grit on a sandpaper. We're trying to do some really aggressive cutting here. and we're going pretty deep. So we want an aggressive grit on our quote-unquote sandpaper. And so, yes, my laser does go down to 45, but a lot of people's only go down to 50. So I'm showing this using a 50 frequency. And you can see my speed, power. A lot of people say don't run your laser on max power. So that is why I am running it a little lower than that. Bidirectional crosshatch, 0.05 millimeter line spacing. And we are going to do it at a 45 degree. The other thing that I want to point out is we are doing 25 passes before we go and switch over to our cleaning. And our cleaning is just going to be one crosshatch pass at 90 degrees. Much faster, much lower power. And what that's doing is this is doing all of our ablation of material and actually getting rid of all of the volume of steel that we're cutting through, whereas this is just going to come back and it's going to just lightly and quickly pass over it to give us a nice even floor, and that allows us to come back and do some more cutting. The cleaning also has the nice added benefit that if you've got slag building up anywhere, it'll help get that out of the way as well. The last thing I want to focus on is the global passes. It is going to take more than 10 global passes in order to get through this material. But I've got it set up to do 10 global passes because after you get done with about 10 on my machine, and you should test this for yours, just this adds efficiencies, not quality, but after I got past about 10, my laser's gone down so deep in the material that the focus is no longer optimal. And I just am basically spinning my wheels running at any more than 10 global passes at that focus level. And so what I'm doing is I'm running those 10 passes, I'm turning my laser down by one full turn of height adjustment, and that'll be specific to your laser. Basically, do a test and just lower it until the sparks are nice again. And then I'm running 10 more passes. That generally gets me through most slides and barrels. For this particular slide, because it's got some thicker areas that we're cutting through, I ended up running a third set of global passes. So I actually went all the way to 30 global passes by the end, and I had lowered it twice. But really, that last pass, as you'll see later in the video, that was just to get through the very tip where things really thickened up on the slide. So you might not encounter that. But these are the settings that we'll be using for both pieces and the same strategy. All right, let's take a look at framing this up. So I'm going to frame it up with my tool. I'm going to make sure first that the tip at the nose is in the correct place, and then I will use my side rails to ensure that I am straight down the slide as well. I can then come back, and what I will do is I will turn off the framing on my tool, and I can just frame where the window is going to be, and then we'll go. I went ahead and paused the laser here because I forgot to put in some material to absorb up the laser after it breaks through, so that I'm not cutting into, say, the bottom of my slide in certain areas or my vise. Here we are getting towards the end of the first set of 10 global passes, and you'll notice that the brightness and the sparks coming off the laser have been significantly reduced due to it having cut down and changed the focal distance. Here we are about to start the second set of 10 global passes, and I have lowered the laser to refocus it, and you'll notice I am back to a nice, bright, and vibrant ablation. I paused the laser after a couple passes here to show you that we are starting to get through. And then I paused it again almost towards the end of this second cycle. And you'll see that in most places we are actually already through, except for just up at the very front where the slide is a little thicker. In this clip, we're almost at the end of all of our passes. And I want you to pay special attention to what the laser looks like as it goes around the perimeter of this window. You'll see that it drastically brightens up all the way to the right side, as well as now along the bottom edge. It's doing that at the right side because, again, as we've mentioned before, that's the thickest area, and that's where it's doing its final little last bit of cuts. But getting brighter along that bottom edge is a hint that we are almost through everywhere, because that is the result of the piece trying to fall through, but being held ever so slightly and by some area. And so it's tilting, and that's now putting a piece of our bit that's about to fall out in the laser's path on the close edge, and therefore it's bringing that focal point back up and it's sparking. So this is always a good sign that you're almost done. Because barrel's around, the only surface that I have that is in focus that I can use to frame is the very center of the top of the barrel. So I use a line as my framing tool instead of a square, and I line that up to center lines I've marked on tape. I also keep the barrel perfectly flat and parallel with the laser with those Allen keys while still holding it in the vise by the bottom. I'll turn on and off lights as it helps me see some stuff over others, and then as long as my cutting area is outside of the tape, I won't bother removing it, and I'll just get going. We're about to start the second round of 10 global passes after reducing our focal distance, and you can actually see the little nubs in the center of the circles where that's the material left over. Pretty cool. The next clip is very towards the end of the second round of passes, so we are starting to see things start to break through and tilt and get hit by the laser. Since these little nubs in the center are so small, they'll actually take a lot of heat and glow really red, so you can really see the final tilt happening on barrels. One more pause here real quick, because I want you to listen to the laser as well. Hear the sound it makes when it's still trying to break through that last little bit and it's hitting the little nubs. And then finally in the next clip where it does bust through, it's almost got a whistling hollow tone to it where it's broken through into the tube of the barrel. And so you get that different tone. And that's how I'm knowing that I'm all the way through. Let's talk results before we do any work to potentially clean things up. So as you can see, we do have a little charring. I'm not worried about that. A little halo of brown almost on the top. But it's easier to look on the piece that came out. It's not the world's smoothest surface. It's not bad, but it's not the world's smoothest. Oh yeah, an interesting note. While we were cutting, I kept shining a light in on the paused laser so that you could see where it had cut through and where it was having more problems. Being able to see the piece that came out now from the side probably helps you visualize why that was the case. So it's ever so slightly thinner back here, then it gets ever so slightly thicker, but right up near where the barrel leaves the slide, it's a lot thicker. And that was that final piece that was holding on, that when I shone the light, you saw clearance all the way around,
but that little tiny end was still holding on because it's thicker, you can see. And so as that started to finally give on the last couple of passes, that's when you saw it start to cant and lean, and that light started hitting on this edge because that's how it was leaning. But yeah, pretty cool to be able to visualize that. Side note, I would have no qualms about blasting this out. Like, that will blast out for sure. But not everyone is going to be blasting. Not everyone that has a laser is also going to be Cerakoting. Doesn't mean they have a blast cabinet. And so let's talk about potential ways to clean this up with, if you're not going to go Cerakote. And that's especially going to be helpful on, say, the barrel, which it's much less likely that someone's going to Cerakote the barrel when they're done than, say, the slide. We can take steel wool and address the problem that way. Now, I'm a much larger fan of real steel wool over this synthetic stuff, but this was what I had at hand. So, and you can see it cleans up pretty dang quick, at least that like halo of color. Now we do still have a slight difference of top, middle, and bottom. You see that? It's like a little slight difference, but we did get rid of that little brown. I don't think that's problematic. I think if you went and steel wooled this and you were left with just the surface, that little kind of tricolor surface, I don't see that as horrible, and I would seriously doubt anything but the pickiest of customers would complain about that, especially when it's on the side of an inside of a slide. So you can steel wool this out, and obviously the more gumption you put into it, the more you're going to smooth things out. If you really wanted to get fancy, you could go sand, but I mean, we're trying not to do manual work here. A laser is an automated manufacturing tool. We want to let the automation do as much work as possible and have us, the human, do as little as possible. And you can see very quickly we were able to clean up the top view. I'd call that a pretty good win, and that's even without me steel wooling the inside here. But you could make it even better by doing that. Let's go see how this blasts out. And here we are with just a quick blasting to hit the top surface and the inside of the window. Let's see if I can catch it. You see those striations up and down? That's the surface imperfection that I'm referring to. It's not horrible. I have a great light source coming in this direction. That's why we're able to see it. If I were to turn that off, actually, you're going to have a much harder time seeing that. So I might eat a little bit of crow. Like, this is a pretty good result, but at the end of the day, I stand by my evaluation that the surfaces coming off of my CNC are much cleaner, and windowing the slide took forever. The barrel's pretty quick, but all in all, this was over an hour. Plus setup. Setup's going to be about the same on my CNC as it is on the laser in terms of like time it takes me, but the CNC is going to have something like this cut in a minute, something like this cut in probably about a minute as well, whereas this was over an hour for both of these things, like decently over an hour. Probably pushing an hour and a half if I had to guess. I should have timed it. I apologize. Yes, I stand by my evaluation that I would rather do this on CNC, but as you can see, the result you get is passable with the laser. So if that's all you've got, it definitely does work. And as we can see in just a second, I can take the same steel wool and with a few swipes, yeah, I liked it the other direction better. With a few swipes, I've got a great finish on this too. I might take like a chamfer bit and just chamfer the top edges of these. I can feel a little burr almost, but yeah, that's really nice. if you wanted to see them together. There they are. After all of my hemming and hawing, I've actually decided that I'm going to keep the lasered slide and barrel as is. I'll blast it out and Cerakote it. It came off good enough. I put the aggressive light source back on so that we can see any and all surface imperfections highlighted to the best degree possible so we can be extremely critical about our results. And as promised, we will compare the lasered results to a CNC'd result. And if we look here, let's start actually with the slides. If we look here, we can see that there is nothing to complain about on the side or floor finish, because this has a floor too, of the CNC'd slide. We already saw that we have some slight up and down marks on the lasered, but by the time that gets Cerakoted, you probably won't notice that at all. So let's talk barrels, and this is going to be very hard because you really can't get a view with light down in there very well. There we go. So you can kind of see in that first hole that there is some surface imperfection, but again, because these holes are so small and where they are situated, it's going to be almost impossible to tell that there's any surface imperfection inside there. But we have a chunk port on the front of this CNC'd barrel, and so we actually can be extra critical of this one. And as you can see, we've got a very, very, very nice shiny finish on the surface of that chunk port that you can see there. And so it would be the same quality inside these holes as well, as that was run with the same bit and the same settings. So again, yes, we do get a slightly better result out of the CNC mill, but like I said, I'm happy enough with the result directly off the laser that I am going to move forward with this